today. Now we're going to go through chapter 3 fairly fast. It'll be 2 weeks. You'll have your test next Friday for chapter 3. It's a really quick chapter. In fact, so quick, the high school doesn't cover this. So if you have friends that are in the high school taking Trig, they'll actually jump ahead of us for a little while and be ahead of us because they skip chapter 3. I find it important for a couple reasons. One, the major part is multiplying matrices and how they work and how you can actually read them, because then we use that in chapter 4 when we're solving matrix or solving three variable systems. So right now, we're going to do 3, 1, and 2 today. Okay? So we're going to go fairly fast. You have your learning goals down. You're going to answer questions 1 through 3 on page 102. Okay? That should be your focus over the next about 5 minutes here. Attention up here, please. Sounds like we're ready to roll, so here we go. Number 1, matrices. If you remember back when we did this earlier in the year, number 1 says, it's page 102. Okay? Number 1, explain how you can modify the matrix to include data for additional countries. So we're looking at this from this graph. We take the data from the graph, we've organized it based upon the country and the production, the consumption. We've put it in this matrix. If I wanted to put, say, like Germany in here and Italy, okay, how would I modify my matrix? Lee?
Add another row.
Good, I'd have to add rows. So if I wanted to put, say, Germany down here, okay. Those of you at that summer academy, how many were at the summer academy? We did the little Seinfeld thing, and he goes, Germany. Okay. That's all I can think of when I say Germany now. So you gotta watch it. It's Seinfeld history lesson. Yeah, it's pretty funny. Anyway, that's beside the point. Sorry. So add a row. Number 2, rewrite the matrix as a 2 by 3. Okay, now 2 means, what does this stand for? Rows by columns. So if you'd forgotten that, remember it's rows by columns, or really cool, right? Try to remember it because it's a really cool way of remembering it. Really cool. Rows by columns.
This lesson is going to be really cool.
Yeah, it could be, yeah. So label the rows and columns. So if we rearrange this, now let me take Germany out of there because they didn't make the cut here. Okay. Sorry, Germany. Okay. So if I wanted to rearrange this, I'd put the countries up above and production and consumption on the side. So production, consumption, and then we'd have China, Russia, and U.S. Okay? Production for China is 9.5. I know, I will. Consumption for China, 9.5. Russia, production is 13, and consumption is 9. And then United States, we got 19 and 25. Okay? What are our new dimensions there? Yeah.
2 by 3.
Yeah, it's 2 by 3. Okay, 2 rows by 3 columns rather than 3 rows by 2 columns. Okay? Explain the difference between a C by D and a D by C matrix. Well, it's kind of what we just did, right? Versus having a 3 by 2, we have a 2 by 3. Yes, I do. Thank you. Okay, any questions? All right, next piece here. I want you to take a look at example 2, question 4 on page 103. Okay, you guys get about 2 minutes, 3 minutes on it with your neighbor. Go ahead. All right. Hey, you're done talking. Okay, you identify a matrix by its position. If you remember, we call that an element from earlier on. Each position, whether if it's, you think of it as its address, and this is going to become a huge importance when we multiply matrices later. Okay, so if you're in row 1, column 1, that's A11. Row 2, that means row 2, column 1. So we call that A21. And 3, 1. A row 2, column 3. So row 2, column 3 is A23. That may not seem like a huge deal right now. It is a very big deal later this week when we start multiplying matrices. Okay? So if I'm finding G32 first, why did they change the name from A to G? Because it's what?
They're talking about gymnasts.
It might be why they call it G. Tyler?
Is it to show us a different set of data?
Yeah, it definitely is a different set of data, right? Here you're dealing with matrix A. They're saying matrix A is this. Notice each element was called an element of matrix A. They used a lowercase letter. This is matrix G. Okay? So when we're talking about an element of matrix G, we're using the lowercase g. Everyone see that?
Mm-hmm.
On your last test, some of you, when we had matrix E, you were still using the letter A for matrix E. Okay, we don't call every matrix A. It just depends upon what you've named it. Maybe they called this one G for gymnast. Okay? But they're calling it matrix G. So element G32 means the third row, second column. Okay? What does that represent? Well, it says 9.95. That's not what it represents. Yeah?
It represents Dominique Dow's on the uneven bars.
Represents what?
The Dominique Dow's girl on the uneven bars, which is above
Brother.
on the textbook.
Yeah, so if we actually look at the table in the textbook, it represents this person right here, Dominic Dow's on the uneven bars. That's the data we've taken out, put into our matrix. So right here. Okay, good. Nice work. Any questions there? All right. Next step, I want you guys to take and define equal matrices. And actually, so if you need to pause on your assignment now and come back to me here. What's an equal matrix? Yeah.
If they have like equal dimensions and equal corresponding elements in the equal matrices.
Very good. If they have equal dimensions, so like this one's 2 by 2, that one's 2 by 2. This is right out of your book on page 104, so it's a little faded, but you can see negative 0.75 and negative 3/4. 1/5 is 0.2. 1/2 is 0.5, and negative 2 is negative 2. These are equal matrices because their corresponding elements are equal. So when I look at number 5, our S and T equal, justify your response. I want you to tell your neighbor yes, no, and why. Okay, how many say yes? How many say no?
Yes.
Anyone tell me why they're not? Someone that hasn't participated yet today. Parker.
Because they aren't corresponding. Because 4 is not equal to 9, and negative 1 is not equal to 3.
Good. Their corresponding elements are not equal. 4 doesn't equal 9. 3 doesn't equal negative 1. 0 equals 0. But negative 2 doesn't equal 2. So all corresponding elements have to be equal. Any questions on that? Okay, with that being said, that allows us then to kind of take a look at these problems, these type of problems. Solve this if it's equal to that. Now, when we say matrices are equal, that means we are saying their corresponding elements are equal. That has to equal that. Obviously, negative 5 equals negative 5. 3 equals 3. That would also mean that this would equal this. So when you're solving these type of problems, you don't know what this is, but you know what that is. You can set up an equation. S plus 8 equals 38 and solve for x. And negative y equals 4y minus 10. You're able to then solve for y. Okay? So I want you to solve for x and y here and then set up your equations on number 7 to solve for x. Okay, so on this one here, subtract 8 from both sides, x equals 30. Okay? And this guy here, we can bring the 4y over there by subtracting, so we get negative 5y is equal to negative 10. Divide by negative 5, y equals 2. Okay? Don't tell me the equation we use on this one here. The first one. Yeah.
3x equals negative 9.
Good. So we can solve that. 3x equals negative 9, telling us x equals
Negative 3.
negative 3 with enthusiasm. Okay? And if x is negative 3, we can plug that in here. We get negative 3 plus y is equal to that then equals that. Okay, so that gives us negative 3 plus y equals 4, so y has to be 7. And we could test it right here. We could put in our negative 3 and we could put in our 7. We get negative 3 minus 7 does give us negative 10, so we're good to go. Okay. Any questions? That is 3-1. Rate yourself 1 to 5. You got it? Struggling? Okay, I'll be walking around. I'm going to give you 2 is adding and subtracting matrices. So if you're taking your notes on it, adding and subtracting isn't too darn difficult, but there's a couple things that I need to show you that's going to help you out. So first, if you're going to get your title down, then do it if you're using the other side of the note page. Okay, your learning goals, and the first thing to do is just to kind of look at the definition of addition matrix or matrix addition. You don't actually have to write it down, but I think that'll help you out quite a bit, and then we'll go through one of the examples together. See you guys that later. Yeah, that's a good point. Hey, adding and subtracting matrices. So when you add matrices, you're adding their corresponding elements. So in order to add, say like if I had number 6 on page 110, if you're kind of following along in your book, if I'm trying to add that, I'd have to make sure first that the matrices have the same dimensions. Okay? In order to add matrices, they must have the same dimensions, or otherwise you don't have an element to add. Okay, so if I go 1 and 3, my new matrix would have a total of 4 for that element. Okay, so you add the corresponding elements. And notice the matrices should be the same, the resulting matrices should be the same dimension as the 2 you're adding. Negative 2 and 9, just add those 2. Oh, thank you. That's very poor. Negative 2 plus 9 give us 7. And then we'd have 0 and negative 3 is negative 3. And then we could add 3 and negative 9. So use different shapes here to kind of help us follow. But 3 and negative 9 give us negative 6. Okay, you have negative 5 and 6 is 1. And then you have, I'm running out of shapes. I don't even know what to. A what? Ooh, yeah, a diamond. I'm not drawing a flower. Jeez. All right, 7 and 12 is 19. Phew, thanks for helping. Okay, 7 and 12. All right, so your beginning matrix had a 2 by 3. Your resulting matrix also has a 2 by 3. Okay? The dimensions have to be the same so that you have the parts to add together. Any questions there? Okay, why don't you take a look at this. Number 8. Use matrix addition to verify the following is true. Okay? Why don't you tell your neighbor if number 8 is true, yes or no here, and why. It's true, right? All they've done is they flipped the matrices around. If we call this one matrix A and this one matrix B, they've just moved them around. That's now B and that's A. So here you're saying A plus B is equal to B plus A. Right? We know addition is commutative. Like when you're doing 2 plus 3, that's equal to 3 plus 2. We just need to know if the same rules apply to matrices. And they do. When you're adding, they're going to be the same. Okay? However, let's try some subtraction. Okay? If I'm subtracting this matrix, this would be a good one to put in your notes. That way you can show the rules. Subtraction is a little different. So, do you recall back when we subtracted numbers, like negative 2 minus negative 4? Now this has nothing to do with this matrix over here, right? Checking out my bling. Okay? Negative 2 minus negative 4, remember we wouldn't subtract. We taught you to add the opposite or do the 2 mark rule or write it as a sum. Okay? That ends up making it a little easier. Negative 2 plus 4 is 6.
No.
Oh, okay. Just making sure you're paying attention. Okay? It's negative 2. Right?
Sure. 2.
Oh, it's positive 2. Okay. Just want to make sure we're paying attention. So Hannah's paying
Can't even
attention.
see it.
Well,
Oh,
they
see you.
There you go.
Oh,
have
thank
me,
you.
that's all.
Thanks for sharing that. We couldn't see it. All right. Hey, if we're going back to this one, when we're subtracting matrices, we're going to do the same thing. We're not going to subtract them. We're going to add the opposite. So we're adding, we're changing to plus, and then we're flipping all the signs in here. Now, 0 we can't flip, but that becomes negative, negative, and negative. So if it was positive, the element becomes negative. If it was negative, the element becomes positive. And now you just do the same rules you did when you were adding. Okay? Just add them all. Okay, now some of you will go, why can't I just subtract them? You can. You just will make more mistakes that way. So if you write it as addition and flip the signs, you make less mistakes.
But if you subtract -3,
Like
that
here,
would just be 6, right? No.
Negative 12.
-9 plus -3 now. So you're counting up the negatives.
Oh, so we switched the
Crazy.
Yeah, switch that sign.
switch. So then we're adding them.
Right.
I got you.
Just
The watch doesn't work. It's like that.
okay. So our resulting matrix would be that guy there. Is subtraction going to be commutative?
No.
Subtraction is never commutative. It's not commutative here either. Okay? All right. 2 last pieces here. Okay? Any questions on that?
No.
All right. Last piece. Actually, before we do that, there's a comment for you. Just because. That is funny stuff, dude.
I don't get it.
Lord.
He's yelling for 16, it means 4.
He's yelling 4, dude. 4.
I don't.
You get it? You know, in golf when you hit it.
When you hit the ball in golf to make sure no one gets hit, you yell 4.
And he yelled root 16.
He yelled root 16.
Or if he's like, we were geeky
Forget it. All right. Here we go. Example 3.
Whatever.
Okay? We're going to solve some matrix equations here. Okay? Solving matrix equations. This says if I want to solve the equation x minus that matrix is equal to this, the first thing you have to do, like if you were solving an equation x minus 5 equals 7, how do we solve that? You'd add 5 to both sides, okay? Well, the same thing applies in this one here. To solve this, if I want to move this, I need to add this to both sides. Okay? So I'm going to add this part over here and add it here. When I add this matrix to itself, I end up with 0. So I'm left with x plus 0 or just x. And when I add this matrix to this, I get 1, 2, 11, and 11. That's a matrix equation. Now we're going to use this a lot when we deal with matrices later in the chapter. This is just the beginning of it. It's to make sure you understand, hey, matrices, when you're solving matrix equations, you're doing the same thing you did back here. These are kind of like the branches you hold on to. Okay? All right, with that being said, I want you to try one of the ones on your paper. Let's try number 18 off your assignment on that side. I want you to solve number 18, that matrix equation right now. Okay? Yeah. A tree has made its ultimate sacrifice so that you have something to write on. I mean the paper, right? So use it. Find a separate sheet of paper. Your work on this, I'll assume that you're showing this stuff. That part is being added, it's gone, and you're adding it over here. So x equals, if you just show that, okay, 0, 4, -6, and 8. So x equals that. Wait. Oh, the 0. -1 and oh, sorry, that's -2. -2. Thank you for pointing that out. Got another student following along with the lesson. All right. Thank you.
Now you got 2 students.
Now I got 2 out of my 34. 33 because that makes. All right. Any questions?
And when you're subtracting a matrix, then you just flip the whole thing. Like, example 20, or number 20.
Number 20?
So, see how you have to subtract it?
Subtract that over there, yep. Then you would add the
So you
opposite.
just flip the
Yep. So why don't you guys try number 20 right now? Good call. It's all part of your assignment, so go ahead and try 20. Okay, so if you're subtracting, right, this part's going to disappear. It's going to equal 0. You're left with x equals, and then use your 2 marks. Add the opposite. So plus, positive, 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 and then the 0 doesn't flip. So you end up with negative 3 plus 2, or negative 1, negative 2 plus 4, or 2, 3, 0, 3, and 2. Note your dimensions should be the exact same as the ones you started with. And if you're trying to solve and they don't have the same dimensions, you can't solve them. Any questions there? Okay. Hey, taking a look at example 2. Example 2 could be a real big pain. It says use matrices A, B, C, D to find the sum. So where it looks like, hey, there's not a lot of work, there's tons of work right there. Okay? Now here, up here, I don't expect to see a lot of work shown. I just expect to see your resulting matrix. So you just put the new matrix there. Here, I expect that you're doing these on your calculator, which means you would have to know how to do them on your calculator. So you need a calculator, and we have about 5 minutes, so do it quick. First, to enter a matrix into your graphing calculator. Let me zoom out just a bit here. To enter a matrix into your graphing calculator, you're going to have to go to where it says matrix. Okay? So that's second. So if you're second, x to the negative first power.
Oh, got it.
And now it says, now there are 2 screens on this that look identical. Okay? There's names and then there's edit. Notice they look the same. Edit means you can change things. Names means you're selecting that matrix. So I want to go to edit. So arrow over to edit. And I'm going to enter some stuff in matrix A. Now the first thing you have to tell your calculator is, what dimensions do you want? So I want a 2 by 2 for A. So 2, enter, and 2, enter. And then notice the matrix changed. Okay, and I'm going to enter 2, and when I hit enter, it goes to the right. So you're doing the row first. So 2, 3, and then negative 4. When you use negative, please make sure you use this negative. It's not minus 4, it's negative. If you use the minus, you're going to get some error message here in a minute. Okay, so negative 4, 5. That's matrix A. I'm now done with it. I'm going to hit second quit. And now I'm going back to matrix. I'm going to go to edit. Notice now I have something in matrix A. I'm going to go to edit and enter matrix B now. So I need to go down to B and hit enter. It's 2 by 2. I'm going to put negative 1, 2, negative 3, 0. And second quit. Go back to matrix, go to edit, go down to C. It's a 2 by 2, 0, 0, 0. 2 by, it already is 0 just by default. Hit quit. Go back to matrix and enter matrix D. It's a 2 by 2, negative 6, negative 5, negative 2, negative 1. Now I'm curious. Will it let me actually hit minus 1? So notice when I try to hit minus 1, it gives me a syntax error. So I'm going to go back and hit negative 1 and hit quit. Now you'll notice under all my matrices. Done? Okay, hold on a second. Under all my matrices, A, B, C, D, I've got them all there. If I want to add A to B, pay attention right here. If I want to add A to B, I am going to go into, let me go back to quit. I'm going to go to matrix. And where it says names, I am going to hit under names. Now I'm just going to select A. Notice it gives me an A, matrix A. So that means it's taking this whole thing you just programmed in, you hit plus, you go back to matrix, and you select B. And then you hit enter, and that's your matrix. That's your solution.
Yes.
Okay, now that you've done all the work of typing it in, all you have to do is select them.
Hey, I got that one right.
Okay, now, some of your calculators show it a bit differently. If you have an 83, it'll show some weird parentheses trying to make it look like a matrix. That's okay, it's still a matrix. Okay, old operating systems would do that as well. Any questions? All right, man, there you go. Finish up the other side, that's your homework.